Today we are going to learn about one of the chapter of class 9th chemistry, that is atomic foundation of matter. This is having the connecting chapter in 10th standard also, that is chemical reactions and equation, metals and non-metals. Somewhat it is helpful in there also, and it is very helpful in the carbon-innate compounds, where there you can learn about the valency, valence electron, stability, all the things it related. It is there. Now let me know about the atom first. What is atom? The basic building block of all matter in the universe. So this is the basic building block we consider of all the matter. Let me know about the matter first. What is matter? Matter is anything whatever you see, whatever you feel, that it considered as matter. So feeling in the sense anger, happiness, all these things is not considered as matter because they are not having any mass, right? So that's why it is not considered as matter. So I am holding the pen here. This one occupying the space on my palm, and it also has the mass, so that's we can consider this as a matter. And total 118 elements are there in periodic table, all it's considered as matter. And some of the compounds like water, food, all the things, even mobile, board, walls, bricks, all these things considered as matter. And in these matters are considered basic building of. What is mean of basic building? In the sense, all matter is made up of something basic, tiny unit. That tiny unit only we can consider as atom. And this atom is first introduced, and we go through the Indian philosopher. His name is Maharshi Kanada. He said same definition, but he called it as Paramanu. Paramanu in the sense atom only. But who coined the atom, the definition first? The Greek philosopher's names it will come, Democritus, Leucippus. So next let me know about the molecule. What is molecule? A group of two or more atoms combined together by chemical bonding. So here first it is a group of two or more atoms. They are combining by chemical bonding. When the atoms they combine, they will form the bond. That it may be single bond, double bond, or triple bond, we will come to know later. Now why they are combined, that is very important, because of stability we can say. See, stability, there are total 118 elements are there in a periodic table. In that 6 of noble gases, they already attained this stability. When it is comes to helium, that is duplet formation, in the sense in outermost shell, that is a K shell, or energy level equal to 1 also we can consider. It is having the 2 electrons in K shell, means 2. In K shell capacity is 2 electrons holding only, so maximum electrons already it is held, so duplet formation is there, so it is stable. Like neon also is there. Now neon atomic number is 10 and mass number is 20. So already you know its number of proton will be 10, number of neutron will be 10, 10 plus 10 it will become 20, its mass is 20, and total 10 electrons are there in its orbits. So its electronic configuration also I can write EC electronic configuration 2,8 means 2 electrons in K shell, 8 electrons in L shell. This is considered as K shell, this is considered as L shell, KL. Then after L, after that M and N, O, P, Q, R, like this it go on. When the atomic number is increases, the number of shells also it can increases. So here it forms the octant. Octant in the sense in outermost orbit. Here outermost orbit is L shell. In the neon, L shell is the outermost orbit. In L shell total 8 electrons are there. 8 electrons in the sense octant formation. If any element in a periodic table, if it is having the in K shell 2 electrons, it should be outermost shell. In 2 electrons it duplet formation. In except K shell, if it is having the one more layer, means outermost layer here is L, it is having the 8 electrons, means that is considered as octant. Means duplet or octant formation is there in the element, then we can consider it as a noble gas configuration. Sir, how many noble gases will be there in periodic table? Total 8 noble gases are there. Sorry, 6 noble gases are there. They are noble gases: helium, neon, argon, krypton, xenon, radon. Total 6 noble gases: helium, neon, argon, krypton, xenon and radon. So these, except this helium, duplet formation is there, remaining all are having the octant formation. Means they are stable, they not need to form the molecule. Only they exist in the atomic form, means single atoms are there. Then the remaining all are forming the octant formation. Like neon already I shown here. Like that, when it is go to argon, krypton, xenon, they also having the outermost shell 8 electron, they are stable. Then what about the remaining elements? How they can achieve this noble gas configuration? Means in the sense octant, how they can formation. When they form octant, then only they become stable, otherwise they not become stable. So how others atoms become stable? Two things here. Then one is sharing and another one is by transfer or accepting the electrons, it can, stability can be gained. Sharing, when they share the electrons, it form the covalent bond. A sharing in covalent bond formation will be there. Let me know one of the example here. Hydrogen atomic number is 1 and mass number is also 1, and one proton will be there and one electron will be there. Now what it do? See, here it is having in outermost shell only one electron, means it is not stable. Stability purpose in outermost shell, if it is K shell duplet, it should be required. So it should be have the nearest noble gas configuration, that is helium. It should be go and share and it become a stability. Now how they can share? There will be two hydrogen atoms, they can mutually share one electron, sharing. So this is the one hydrogen atom and this is another one, they are sharing one, means, so here also 2, so here also 2, means each they are sharing one electron and they become stable, means duplet formation takes place. We can also write like this also, H single bond H. Why it is considered as single bond? Means one pair of electrons, hydrogen here's one electron and hydrogen here's one electron, they are sharing each other. Here see, here sharing each other, so single bond, one pair of electron they are sharing, means single bond formation will be there. What about if they share more than one pair? If then if they share two pair, then a double bond. If they share three pair, it is a triple bond. Triple bond it will be there. No, four. After 3, 4, 5, 6 bond will be not there. Up to triple bond will be there. Now let me know about the oxygen. It formed the double bond. How it formed the double bond? Its atomic number is 8 and its mass number is 16. Its electronic configuration, how the electrons are arranged in its atom, that one electronic configuration we can consider, that is 2, 6. 2 electrons in K shell, 6 electrons in the L shell. See, so I am taking here 6 electrons only in outermost shell. K shell I not drawn here because already duplet formation is there, they are not involved in any chemical reaction, that 2 electrons inside. So these outermost orbit electrons only, they are sharing electrons, formation, the molecules, all these things takes place. Now see here, one of the oxygen structure I draw, there is outermost shell, that is L shell I took. L shell, 6 electron, 1, 2, 3, 4, 5, 6 electron already drawn, and there will be 2 oxygen atoms, they will mutually share 2 pair of electrons, means 4 electrons. One oxygen atom will share 2 electrons and another oxygen atom will share 2 electrons. So they can sharing and they obtain the octet formations. Check. This is the one oxygen atom. In this you can check 1, 2, 3, 4 electrons already she has. 5, 6 it's already it is there 6 electrons, and here it is getting 2 more from another oxygen atom. So total 8 it will become. So octet formation is happen one of the oxygen. Now let me take the another one oxygen atom. It is having the 1, 2, 3, 4 already it is there. 5, 6 its own, and it is getting the 2 electrons from other oxygen. Means total 8. Means here sharing of electron is 2 pair. 2 pair in the sense we can consider as double bond, oxygen double bond. You can write like this also. And in nitrogen triple bond will be there. 3 pairs of electrons will be shared. Triple bond formation will be there. Next, it is regarding the covalent bond. Why it is considered as covalent bond? In the sharing of electrons takes place. Sharing. I will share some electrons to you, you can share some electrons to me, both it become stable. So I shown here only elements, hydrogen and oxygen. Even I said about the triple bond in the nitrogen. The same thing it happens in compound also, like water. Water is there, its formula is H2, its formula is H2O. It's a compound, or the molecule also you can consider. Now, how these can be stable? So you can check it out. The oxygen, let me take oxygen, is having how many electrons? 6, 1, 2, 3, 4, 5, 6 electrons. It required 2 more electrons. In the sense, it can take from one electron from the hydrogen, this is oxygen. Okay, now 1, 2, 3, 4 it are 5, 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is obtained its octet and hydrogen obtained its duplet, 2 electrons. Right, 2 electrons. So both sharing each other, it can form the compound, and it is also considered as covalent bond. In a compound we can consider sharing it takes place. Now let me know what the by transfer and accepting the electrons, how they attain the molecule. See here, transfer, the electrons is totally transferring to another. When electrons are transferring, means negative charge, electrons are negative in charge, they are transferring the negative charge, and that element become positive in charge. Negative, electrons will donating and it become positive. And someone is donating, there will be some other atom, they should be accept. It is accepting the electron, that negative charge will be more, that it become negative in charge, or anion also we can consider. Let me check now how it happens. Now sodium, symbol is Na. Its electronic configuration is 281. K shell 2 electrons, L shell 8, M shell 1 electron. We know that last shell electrons only involved in the bond formation, means it's 1. So 1 electron, it easy can donate this 1 electron. See, sodium is element here. All the elements, most of the elements, it can donate the electrons and they become the positive in charge or cation. See, it can ready to donate 1 electron. So I cross item means it is having the 1 electron we can consider. And to whom it is donating? It is donating to chlorine. The chlorine should be accept 1 electron to get the noble gas configuration. When it donate sodium 1 electron, its electronic configuration just 28, and Na become Na plus, means 1 electrons it's given out. Now chlorine atomic electronic configuration 287, means 7 is the valence electron, last orbital. These only involved in the electronic configuration. instead of it will transfer the 7 electrons, it is very easy to chlorine to gain 1 electron to become stable. So that's why it is taking the 1 electron from the sodium and it become 2 8. It 1 it will get, means here also it become 8. So let me check how it happen after this transferring and gaining, how it will become. Na become Na plus, means it become 2 8, 1 electrons it's given and charge become cation, and it's 2 comma 8 comma 8, means 1 extra electron it got. Earlier it is 7, now it become 8. 1 extra 1 electron it gained from the sodium, means though both of them they attained the noble gas configuration. This is 2 8, outermost orbit is octet formation. 288 outermost orbit is obtain the octane formation. So both become it stable. We can write NaCl, Na plus Cl. This one we can call common salt. Common salt or table salt also you can consider. So in daily life we can add the salt in the food and it become tasty. So that common salt only, that formula is only Na. Thank you children, thank you very much.